I gotta mute that stream once it pops up.
Oh, yes.
So, oh.
Oh. I've heard that many times. It's a cartoon thing. Okay, let's see. Is anybody here yet?
Anybody here yet?
What the hell happened to that? Why is it going there?
There we go, just like that. Okay, there we are. Okay. Oh. P&K chat is live. Marc D'Antonio's
awesome.
Chat is live. We are live. Me, myself, Keith, and Marc D'Antonio.
Yes.
Gonna mess some stuff up in Universe Sandbox 2.
We are, because tonight is going to be a night of Universe Sandbox 2. Indeed. I gotta turn my mic on now. Hold on.
We decided since we weren't able to do.
Yes. Hello, folks. Sorry. It's a night of Universe Sandbox tonight. The sky is not conducive to the starry skies, although I have good news about all that. Keith is here with me. Hey, Keith, what's going on?
Oh.
Exactly.
We decided to do a stream tonight, guys, because we didn't get to do one over the weekend where I usually have Marc on P&K, so we decided to crash some planets together. And, what do you normally, the shenanigans we get into.
Exactly. The shenanigans. I mean, besides the shenanigans, we're going to be doing some other really cool things. Like, for instance, this view we're looking at right here, this is Oumuamua coming into our solar system. It's right there. All right. And Oumuamua is going to go around our sun. If you remember back in 2017, Oumuamua came zipping in October, and it moved so fast, literally 190,000 miles an hour, or roughly 83 kilometers per second. Came in so fast, and on Skytour Radio last week, we actually talked about what would happen if Oumuamua struck our planet. Hey, Keith, we might be able to arrange that. Maybe figure out a way to throw an asteroid about the size of Oumuamua into the planet to watch what happens. That might be cool. Don't you think?
Yeah, let's murder everybody.
Well,
a little quieter
and we
than
are.
You, Marc.
What's that?
I'm just reading from chat. It says Keith is a little quieter than you. That might be because I wasn't really talking all that much, but I can.
You could just raise
up,
your levels.
I can up the levels a little bit if you want me to.
I'll raise my levels too a little bit. See, so now I'm even higher than you.
Oh, there we go. So hopefully that'll work out for you. I don't think I'm peaking. I'm still at 0 decibel. Yeah, I'm good.
Very good. Very good.
I
Very
gotta
good.
turn my headphones down because I'm deafening myself.
Yep. I want to say hi to Alfred Grimmett is here. Zarix is here, and Deb Mahern. Hello. Hi, guys. Welcome to Skytour Livestream, and we are also simul streaming over on P&K Space Imaging. Yep. So is in our chat, and in P&K's chat. We're all one big happy family today as we murder the solar system in Universe Sandbox 2.
Marc is paying attention to the Skytour Livestream chat, and I'm paying attention to the P&K chat. So, just work with us. We'll try to see everybody.
Well, you could
a little
just
quiet. What the heck? Okay, you know what?
We could each bring up our own chats. Each other's chat too.
Yeah, that's true.
We can really make it complex. I mean, to me, that's not very complex considering, how many things I run when I do a normal Skytour live stream.
Yeah.
We got lots of things going on.
Yeah. We'll wait till this baby starts crunching some numbers.
Oh yeah, this is gonna this is gonna go fast. And the thing is, I did something with Universe Sandbox 2, which is kind of fun. I actually created a star by throwing all kinds of gas, and you can throw gas, literal gas clumps, into a center of a cloud and make a cloud, and it gets denser and denser until it reaches that fusion temperature. And for hydrogen, that temperature starts off at 13 million Kelvin, and when it reaches that temperature, all of a sudden it becomes a star. So Universe Sandbox is actually, the physics is pretty darn good actually. So it's a wonderful thing,
Yeah.
James Dugan says hi to you, Keith.
Hello, James Dugan.
Yeah, D. Smith is here. Hey, D.
Yeah, D. Smith was over in this chat. That's who told me about the.
Oh yeah,
levels.
They're saying you're quieter on your stream.
Oh, I'm quieter on my stream.
Okay.
Oh, okay. Well, I can fix that.
There you go.
Yeah, I can definitely fix that. You say Marc is loud on my stream, and I'm quieter.
Yeah.
So let me just mute this loud mouth.
Yes, mute that loud mouth.
Let's see. Hopefully that'll work out a little bit. It's a whole thing between 2 channels streaming at the same time off of a Skype that we're connected to that has its own, microphone and volume levels, and then trying to patch it into OBS with its
Right.
2 different microphone levels there.
And supposedly there's music in the background.
Yeah, and supposedly there's music somewhere back there.
Yeah.
But
yeah, I see. I see music playing back there. I just I'm unable to hear it on my end tonight for some reason.
yeah, same.
Anyway, I just want to, just before we start destroying things, let's just take a look at what happens with Oumuamua. This is Oumuamua right here. And Oumuamua was a really strange looking asteroid. It was actually classified as a comet initially, but because it didn't do any things that a comet normally does when it gets closer to the sun, which is to outgas and start shooting off gases and so forth, none of that was seen. So Oumuamua became a spindly asteroid.
What does Oumuamua stand for again?
Messenger
From far away.
messenger. It's Hawaiian, so it's messenger from afar.
Yeah, messenger from afar. That's what it was.
Yeah.
Yep.
I mean, there's several translations of Oumuamua. But in Hawaiian, I don't know how you actually say it. It's like Oumuamua, but it's really interesting, to watch it. So here's Oumuamua, and I'm going to move the Milky Way out of the way. The Milky Way looks beautiful, but it gets in the way. And let's just I'm slowing down the simulation down here in the bottom. Here you can see now I'm going down to 8 hours per second, and you watch when I hit go, you'll see that Oumuamua is still making inroads here and moving fast into our inner solar system, even though we're going 8 hours per second. That's it's actually 7 hours per second now.
Yeah.
We're almost 7 to 8, and you can see what's happening. Oumuamua is coming closer and closer, and as it does, we can actually track it and go right up to it. And people say, well, what's it look like? Well, actually, in Universe Sandbox, they show it as a sphere. It was actually a spindle. It was anywhere from 1,500 to 2,500 feet long, and 150 feet to 250 feet in diameter.
Otherwise, pretty big.
Yeah, it was a needle. Yeah.
Yep.
And when it struck the Earth, if it struck the Earth, it would leave. It would create a crater that was several miles across and a mile deep, depending on the angle and so forth. At the speed it was coming, that was the most important thing. If Earth was in its orbit and just happened to intersect and they got struck, it would hit with the force of over 4 megatons, almost 4.5 megatons of energy, and that's actually pretty substantial for a piece of rock that's only about 1,500 feet long.
Right.
So here it goes down through the plane of the solar system and starts zipping around. Now the gravitational pull. The sun, of course, has been pulling it in the whole time, but look where it came from. It came from way above the solar system up there, and now it's coming through the solar system.
A different plane.
A totally different plane, because the plane of our planets is like here, right? Here's the plane of our planets, and Oumuamua came from way up there. Basically the northern solar system latitude. So it's certainly not an object in our solar system, and it came through on a trajectory that takes it out of the solar system now. This is a parabolic trajectory, so
how certain are they that this thing's actually going to exit the solar system now? Is it moving that fast where they can almost guarantee that it's not like somehow going to magically orbit on a very, very, very long orbit?
No, because the orbital parameters were found with it, and they actually were able to deduce the what are called the orbital elements, and they discovered that it's in I believe a parabolic orbit, meaning it's not going to be periodic. If it was in an elliptical orbit, if you widen an ellipse enough or put enough energy into an ellipse, it becomes a parabola.
Right.
See, so what looks like the focus of an ellipse over here is actually a parabola, which is, it's open-ended. It doesn't close.
Yep.
So it's not orbited, But take a look at this. See here?
Let me ask the people if our levels are good now. I'm thinking they are, because nobody has said anything. But I think, so everybody in P&K chat, I can't see Marc's chat, but hopefully everybody in P&K chat, is our levels good now? We're even? You can hear us both?
Seems like it.
The same?
I'm going to pause it right here, because this is something interesting.
Yeah.
Carolina Sky, hey, welcome.
CSA.
Yeah.
Good channel, by the way.
Yeah, for sure.
Real good challenge.
Notice Oumuamua is here, and notice the Earth is here.
Mhm.
Okay, these two objects were not far apart, in a sense. I mean, if you think about it, certainly a lot farther than the Moon is from the Earth. The Moon is well within that distance over there. But when we check it out, we look at how close it is relative to the Earth. That's really not that far away. That's kind of a cosmic disaster that could have been. You know,
A little bit. Jeez.
well, you know, I mean,
That's
we
very
talked
close
about
on the
that
cosmic scale.
on 2 weeks ago. We talked about the biggest extinction events on the planet. They were caused by the flood basalts in Siberia, the Siberian traps. And unfortunately, you know, or fortunately for us, there's no more of those. But unfortunately, we still have these near-Earth asteroids, these NEOs, near-Earth objects, to worry about. This one was a semi-near-Earth object. It didn't really come that close. But this, you know, when you think of all the space in our solar system here, okay, let's be honest, okay, that still feels a little close to me, you know. So it was close enough, if you ask me. So anyway, we'll keep it going now. So Oumuamua came in and it went, and it didn't disturb anything. It didn't have enough mass to affect any of the planets beyond any known values, and it really wasn't that big a deal for us, luckily. But it could have been a very different story. But anyway, that's Oumuamua, and you know, here on Earth, you know, we have our little planet. We enjoy our world. Now it's spinning really fast here, of course, because of the fact that we are actually doing this time lapse here. So we are using 8.5 hours per second here. All right, and that makes things a little bit different.
Wow.
You'll notice.
Can I just say something?
What were you gonna say?
I'm putting my microphone volume up on my audio device, and it's automatically taking it back down.
Well, I think it's trying to stop you from clipping because you're actually overmodulating.
Yeah, but see, they can barely hear me on mine.
So you are kind of low, actually, which is kind of weird. I've got you maxed.
Yeah, so that's what I'm trying to, like, my microphone volume in the thing right here, I try to put it up, and it automatically goes back down.
Yeah.
Let me go back up again, and it goes back down. So
well, you got to take off the auto setting.
There has to be like an auto.
Yeah, there is. While you're figuring that out, I want to say hi to Dagger Spells and Most Intelligent Ever Born. I said hi to James and Carlos Huerta. Hello there.
I know why.
And Ken Cantu. Hi, how you doing? And I'm just pleased you guys came out to join us. We're actually doing a Universe Sandbox stream. We just showed you Oumuamua as it goes streaming through the solar system. And we're going to have some fun blowing things up.
Right.
You know, because that's Keith's level of entertainment, because Keith is with us tonight. So we're going to have to blow some things up. And hey, let's be honest, it's fun.
Absolutely.
It is fun. It is fun to blow up things. Hey, Spock, move the Enterprise closer. I have to see this.
Okay, it says all that's working. Yeah, you continue. I'm gonna keep on working on this, see if why my volume keeps on going down.
That's fine.
Yep.
You work on that, and I'm gonna sit here and watch Oumuamua leave.
Oumuamua.
Oumuamua instead of Oumumu. Right.
Oumuamua.
It's really cool. Hey there, Joni222. Nice to see you. Marianne, what's happening? I'll be out there to see you again in September to speak at the UFO Congress. Next month, I'm in Norway. I got to speak in Oslo, and Bergen, Lunda, part of the New Science Tour that I'm part of. It's we're doing talks on the new physics that's coming out. It's really cool, and it's stuff that reaches everybody. It's not going to be highfalutin, high-powered stuff. It's going to just be stuff that everyone can understand. And we're going to bring this to the U.S. as well, so that's going to be kind of fun. Charles is here. Charles, how you doing? And for those listening in P&K, I'm talking about those that are in my chat, so
there are two chats open.
Huh?
I said there are two chats open.
That's right. The P&K chat and the Skytour livestream chat.
I bet you.
Yeah. So Oumuamua came and went very rapidly. And if we zoom out, we can actually see the whole the path that it took. That's Earth. Okay. And it actually zoomed through the solar system very, very fast, and then it gone so quickly. We didn't really see it until after it had passed any possible collision point with us. That's kind of scary.
Hey, I might have done it. I might have. Hold on, let me turn.
You are overmodulating too.
Yeah, I just wanted to make sure. All right, there's my output. Am I overmodulating still?
No, not that. Sounds very good right now.
Okay, so people, let me know in the chat, in P&K chat,
Yes.
if that's any louder. Hopefully it is. And if it's not, I give up. But
right,
because I went to the just to the microphone settings instead of the mixer, and set the microphone all the way up. So maybe now it'll let me change. Oh my lord! Maybe now it'll let me change the what you call it. So let's try it.
I don't know.
Levels. How about it? Nope. It still wants to go back down. 100% better though. Keith is coming in clear. There we go.
Okay, well,
voila!
That's better than
Ladies and gentlemen, Keith is live with Marc D'Antonio here on the Skytour live stream. Finally. All right, let's get to smashing some stuff.
Okay. So, what do you want to start with?
Well, you know me, dude. I love black holes.
Yeah, that's true.
Giggity. And as I was talking to you before we started this stream, I wanted to see what happens if we started taking the smallest black hole, like say the size of a golf ball or a softball, and putting it next to a planet and seeing what it does. Like if it has any kind of effect, or what it has, like how big it has to be to actually have a massive effect on the planet it's next to.
Well,
or the object it's next to.
So we can take a black hole that's like let's see, maybe one the size of the sun?
No, make it way smaller, way smaller.
Okay.
I'm seriously. I'm talking like maybe the size of a basketball.
Okay, well, we have to figure out how to do that.
Well, you want your mass to be way smaller than.
I know.
Earth, or what? Yeah, it would be no mass, but no. Would it? Yes.
How do we do that? I want to make sure I can do that here. Giggity.
Giggity.
All right, I'm gonna do one thing first. I just added a black hole, and it's in orbit around the sun now.
Okay.
And if I select it, I think I can.
Yeah, there you go. Parameters. So
use some parameters, and then I can
radius. Make it small. Well, let it have the mass of the sun, but make it really small.
Well, see that the. Oh, the physics of black holes don't work that way.
Yeah, I'm thinking of another thing anyway.
You can't make it have the mass of the sun, but like only be 3 inches across.
I was thinking density.
Yeah. Okay.
Yeah. So like make it like 0.5, and then the radius. Take the radius down to like, because I think you can switch it from kilometers to something else, if I'm not mistaken.
Yes.
Yeah, you can switch it to. Is that really centimeters down there?
What do you want to do it to?
I said, is that really centimeters down there?
Yes.
Okay. Let's click that. Let's see. What's a good size in centimeters? What do you think like is a basketball? How many centimeters?
Well, I mean, we can say 30 centimeters and see what we get.
Okay.
I don't know that it's going to retain its black holiness.
Let's find out.
It's 2 times 10 to the 18th kilograms in something that's the size of a basketball. So I'm going to change this name and say BH Basketball.
BH Basketball.
Yeah, and I wonder if I can. I was hoping to be able to save this object. I think you should be able to save this object, no?
Probably somehow. Once
Yeah,
again,
there's
oh
a
my
way
God!
to
Look at
do it.
Earth.
Huh?
Look at Earth.
Oh, I know. Look, I know. Look at the Earth is already Earth's doing some wacky things. Here's what I want to do.
And that's a basketball-sized black hole.
BH Basketball is black hole.
And it made Earth do that.
Yeah.
Wow.
Yeah, but see, there's something else I want to do. Actually, if we look at Earth, okay, we're gonna find that Earth is
like, I'm out of here, man.
Well, Earth is gonna be suffering some climatic changes.
A little bit.
Yeah.
Wow.
Its surface temperature is now down to 10 degrees Celsius.
That thing, that is the size of a basketball. That's how dangerous black holes are.
Well, it's also got the mass of that sun.
Exactly.
So it's pretty bad. Okay.
My lord.
Yeah. So clearly, and we put this out around the orbit of Mars, by the way. We sucked it up by the orbit of Mars, and Earth was ejected from the solar system by it.
It just said, see ya.
Isn't that cool?
Yeah.
Yeah.
Brian's Bronco Adventure says, a black hole cannot form in less than 3 solar masses.
Well, yeah, of course. I mean, if we're doing fantasy here.
Yeah, we're doing fantasy. We're doing basketball black holes.
Yeah. You know what I mean? And there's all kinds of limitations we're not talking about. We aren't paying attention to the Schwarzschild radius, okay? We're not paying attention to the mass of the star, because the sun could never be a black hole anyway.
Yeah.
Well,
would this be considered a wormhole? Like, what's the difference between a wormhole and a black hole?
Well, a wormhole is actually a theoretical warpage of the space, and it could be caused by a black hole.
So you mean from one point in space and time to another?
Well, that's the supposed theory, but wormholes in practice, first of all, we don't really know they exist, number one. Number two, if they did exist, they may not exist for long. They're only temporary. So, and once one forms, it doesn't mean it's going to come back periodically. It's not necessarily true.
Right. Okay.
Yeah.
So now you know.
Yeah, exactly. I want to know how I save it. There's a way to save this. I know there is. Let me see if I can.
I wonder how big of a black hole it would take to suck our solar system. Giggity.
I just want to be able to take this black hole and save it, man. Or the worst case, I would just like to, take a black hole in existence and make it, be able to save it. I forget how to do that. Darn it all. That's too bad. How about there's one. Let's bring the Earth back.
Okay.
Yeah. What did I do? Okay, what I did was I actually made another black hole. Come on, get out of there. Get out of there. Stop making black holes everywhere.
Giggity.
Yeah. I made this black hole over here. It's another solar mass black hole.
Zoom in on it. See what it's showing.
Actually, it's interesting how you see. I'll look at BH Basketball. Where'd it go? Okay. Let's do that. So if we zoom in, we should be able to. Okay, why am I not able to? Am I in the middle of something here? I must be in the middle of something here.
Must be.
It's going out. And I don't know why that was. It won't let me. Okay, there we go. So now you zoom in and you can see the effect. See, now here's one of the ways that we find exoplanets. okay, is if there's a planet that's running between a distant star, like the sun is in this shot, and its star, then the gravity of the planet will bend the light of the distant star like this. It'll actually cause it to kind of refract around a little bit, to bend around like this, you see?
Mm-hmm.
And what this is this is called a gravitational lens. The gravity of the planet, smaller, much by many magnitudes smaller than a black hole, but enough so that you can actually see a little bit of the starlight getting warped like this. And that's how we find planets using this microlensing technique.
Hey, Mark.
It stands to reason it'll work, though, because we got stars that are usually in the background of the other stars we're looking at. So when we're looking at these stars, that's just something went by just now really fast. We can tend to see a disturbance that occurs because of the gravity well. But
I
that's
just wanted to point
right,
out that we were just looking at Uranus through a black hole. Giggity. It was in the black hole. But you know what? I mean, how does that compare to like a water droplet? How it distorts? Because like, say if you have a water droplet and you have like an object behind it, you know how it distorts the image. It's not really bending the light around it, but it's actually the water droplet itself is playing with the optics.
That's refraction, yeah.
Okay. So it's
very different thing. Refraction is bending of light going when you go from one medium to the next, like air into water.
Right.
But bending light in space is a very, very different thing. When you're bending light in space, you're actually, you're actually warping the space-time continuum. You're warping the fabric of space.
Mm-hmm.
That is the interesting thing. When you talk about light, for instance, like we go back to this black hole, right? When we look at this warpage, you say, well, what is that warp? What are we looking at here? Okay, and I'll use the galaxy. See, now you can see the gravitational lens.
Yeah.
This is essentially the image we saw from the 55 million light-year distant M87 galaxy. This was the image we saw. If you remember, it was like a disc around the center, and they said, look, this is the black hole itself. What it was it was an artifact that was created by the warping of the space by the black hole. And the black hole was what's smaller than this, but the warp was out here, because there's a certain radius in size that a black hole will be based on its mass.
Mm-hmm.
And that radius is called the Schwarzschild radius, and you can calculate it based on the mass of the star that made it. And if you can calculate the mass of the black hole, you can calculate roughly what the original star must have been in mass. And they're all going to be several times the sun to begin with, because nothing smaller than that can be a black hole. It'll become a dumbbell nebula or a ring nebula. It'll become a planetary nebula like that, where it swells up and sloughs off its outer layers. But this is cool.
Fabricio over in P&K chat says, I think the supermassive black hole at the center of the Milky Way galaxy is 4 million times the mass of the sun. He said, correct me if I'm wrong.
Okay, I don't know the exact mass of Sag A. That's Sagittarius A, but let's do this. Let's actually find out. We can do that because we shall now go back and go back to opening. I want to show all of these. How do I do this? I don't want to just show Oumuamua. Let's get rid of that.
By the way, guys, if any of you wanted to get this, it is a game off of Steam, like quote unquote game, but is a physics engine that actually applies real physics. It is nice to have a computer that can handle the calculations. It does take a lot of CPU because it is a hefty program to run on a computer.
Yes.
But it's something that you can get off of Steam. I think it's like $12 or $14 for Sandbox 2. And you can just spend hours creating planets, smashing stuff into one another, making galaxies collide, building suns, whatever. So it's definitely something you can get if you want it, and if you have a powerful enough computer to get.
That's right. It's a beautiful, it's a wonderful program, and it's a lot of fun too. And let's just take a look across the top. These are all the different types of things you can get. There's some core simulations with this, okay? Things like our solar system right here, okay, which I'll bring up. Okay, And okay, so this is like a base one. This is our solar system, and it gives you a little write-up about what about the solar system. What little it says is enough just to get you having fun. Okay, but then there's others. If you go across, you'll see that this is the core simulations. There's a bunch of those. All right, and colliding moons, 100 colliding moons, sphere of moons, a binary pulsar. What do those look like?
So 100 combining colliding moons.
What? Yeah,
play the
moons.
play the 100 colliding moons. Let's see what it looks like.
We will. But then we have galaxies. Look at this. It has galaxy simulations. This version, if you're on Steam, if you have it on Steam, it's updated. This one has just been updated to add more galaxies outside our own. This is our Milky Way center right here. We can pull out of this and go all the way outside our galaxy to see all the galaxies around us too in this simulation. We can look at all the different physics things. Like here's a bunch of them: the Earth and early Moon, back when it was first formed, Saturn and the Earth. Okay, some of these are real, some of these are not real.
Yeah, it's giving you working theories of how they would work, according to the math.
Yeah. And then here's one, when you have tidally locked Earths that are close to each other, what would happen? Okay. Oh, believe me, we're going to have fun tonight. We're going to go back and check these out. Collisions.
Yeah, because you know what? I don't think I've ever watched any of the simulations, like I always created my own and started throwing stuff at planets, like Thanos. So it'd be nice to see what they actually come up with and see how cool it looks.
Yeah, and it's a community out there where you can put them in.
Nice.
Like here, if Mimas, Saturn's moon Mimas, collided with the moon, okay, and in slow motion, this is what it would look like. Okay, Earth and Apophis. If the asteroid Apophis hit the Earth, okay, Earth and the moon in slow motion, and you see what happens. The devastation. Here's the thing: when a planet is struck by something else, a lot of things happen. It doesn't just make a crater. It throws a lot of stuff up in the air, but that stuff it throws up in the air is very hot. It's all melted and molten. So the planet globally is going to heat up really, really hot. And I think, I think that's pretty. I think that's pretty intuitive when you watch it in this simulation. Mm-hmm. You could throw Earth at Jupiter, and all of a sudden Jupiter is now red hot.
Yeah.
And it makes sense because there's a lot of energy expended, and the heat of motion, the energy of motion, the kinetic energy, okay, which is calculated as 1/2 the mass times the velocity of the object squared. That motion is translated into heat. And that's where it goes when it strikes something. The faster it goes, the hotter it gets.
It did, and I noticed there's a way on here, because I've done it before, is you can actually make Earths and planets other than round, and it shows you in slow motion, like what, based on the physics that we know, that we use day in and day out. Like if you make a donut Earth, it shows you exactly what would happen to it once you play the simulation. Once again, you could do the flat Earth if you wanted to, and show that the gravity would just come, crunch in on itself.
I would like to
after
see
a couple
that
hundred
one.
miles.
Find that one tonight if it's here.
Yeah, it's there. You can create your own different shape. You can even try cubes. I think was on there. Once you get to a certain size, that gravity just becomes so strong it just pulls everything in.
Yeah. Carolina Sky asked a question. This program, can we see the exoplanet named Goblin? Yes, we can. Actually, there's a simulation in here for the Goblin at the end of our solar system, and we'll show you that too. I'm just showing you here some more collisions, and then there's a bunch of different solar system things, and then potentially hazardous asteroids within our solar system.
I forgot about that. You can make your own solar systems.
Oh, you can.
Totally forgot about that.
Be honest. You don't have to take what they take. You can make all your own things.
Yeah, you can do a 30-planet solar system if you want to.
Yeah. We can look at the evidence for the 9th planet based on all the gravitational perturbations that are out there. That's really cool, Really, really cool.
Give them their own orbits. Give all the planets their own orbits that you want. They don't have to be like, on the same plane. They can be crazy all over the place, just missing one another. Yeah, it's
we're just looking at things that people did.
Just have the computer power. That's all I'm saying. The bigger it is,
people are saying, "Well, stop talking about it and show us."
Yeah,
man.
I know, right? Shut up, Keith.
Right?
Let's do it.
Yeah, let's do it.
Yeah,
and we're gonna. I'm just showing you so you see different types of planets, okay, And then you can do exoplanets too. So there's a number of exoplanets. Now, some of these are community generated, so they may not be perfect. But then there's a bunch of historical things.
Mm-hmm.
You can go watch the Parker Solar Telescope pass the sun. Accurate.
Let's do it.
The Parker Solar Probe. Watch it. It's accurate. Okay. This is the one that Carolina was talking about. The Goblin at the edge of our solar system. Okay. Let's just start that one up anyway because he asked for it.
Yeah. Let's do it.
All right. Well, there it goes. Okay. Now this is talking about in October how October of 2018 they found this distant object. It's a TNO, a trans-Neptunian object that's out there, and it was designated 2015 TG 287, 387, and that was called the Goblin.
Oh, okay, there it is. I see.
Yeah.
It. Yeah, I see it.
You see it?
Yeah, it was kind of hard right there for a second because it's one of like a light, not white color. It's like a yellowish.
Yeah. Well, does that make
there
it
we
easier?
go. Yeah, that's perfect.
Okay, because this is it right here.
Yep.
Bingo, right there. Yeah, and so it has an orbit that's crazy because it's really elongated or elliptical, and it can go all the way out to 2,300 astronomical units distant from our sun. Now that's pretty cool to have found that, and you can actually see this really long orbit out there. Okay, but then you might say, well, what's this orbit over here? Okay, and that's, I believe, Sedna. Okay, so Sedna also has this extremely long orbit as well, and elliptical orbit. And the Goblin was another one. So these are, again, TNOs. What are they? Well, they're most likely going to look just like comets when we see them, most likely. And this object here, I don't know if they have the parameters for it in here. Let's find out, shall we?
Why do they call them trans-Neptunian objects?
Because it's an object that's an object along with a whole family of everything beyond Neptune that are beyond Neptune. They're in the Kuiper Belt, but they actually have these elongated orbits, and they say trans-Neptunian because they're just beyond Neptune.
Would
you might say, well,
Pluto?
Wait, everything. Huh?
Would Pluto be considered a TNO?
Yeah, actually, Pluto was called a TNO as well.
Okay.
But in fact, we can't technically call it a TNO because of the fact that it does come inside of Neptune's orbit at one point or another.
Mm.
See, just because of its ellipticity, the way its elongation is, it'll actually come within Pluto's orbit. I'm sorry, Neptune's orbit for a small period of time.
I say make Pluto a planet again.
I agree.
Yep.
I told you I sat with Clyde Tombaugh, who found Pluto, on a grassy knoll in Vermont, and he was going to be doing a talk, and I basically was up there at this astronomy get-together as well. And this was many years ago, and he was elated to have a planet that he found.
Yeah, I mean,
and when I asked him
it's not very big. I mean, I get it. It's not your classic planet, but you know what? It was part of our 9 planets for the longest time, and then we get past it with some cameras finally, and it's just showing a big heart and its own little moon, and you're like, how can you not just give it an honorary planet name? You know what I mean?
Yeah. Well, you know what? It's not just a moon; it has 6 moons.
Yeah.
So let's.
And the mass relay is like a little less than a light year away.
And what?
Mass Effect. Remember Mass Effect, the game?
Yeah, I love
the mass relay was supposed to be right beyond Pluto. Oh, the moon of Pluto. What all these years they thought was a moon turned out to be the mass relay. It was encased in rock. Get her done, Garrus.
Use people.
Yeah, I know, right? Mass Effect's a great game. I love it. The original.
Yeah. Hey, Gas Mask, welcome. Hey, Astro Live, good to see you here too.
Astro Live, another good channel.
Huh? Yeah.
Astro Live's another good channel.
Exactly.
Yep.
I'm trying to also see who's out there. So pardon me for not. I'm jumping in the chat. I am checking out the chat.
Yeah, let me run down.
Gas Mask, this is Universe Sandbox 2, as you said. Yep.
Let's see here.
And it's a really good. It's $25, he says, and that's probably
is that what
true.
it is? Yeah. Sometimes they have it on sale for like you know, special occasions and whatnot. And I think I got mine for like 14 when it was on sale one time. So keep an eye on it. You know, if it drops down below $15, definitely grab it as long as you have a computer that can power it and, you know.
Yeah, you definitely need to have a powerful computer for it. It really does need to be powerful. Even this computer, this is a...
I would say an i5 or better, you think?
Yeah. Yeah, i7 probably best.
Yeah, definitely i7 or
and,
i9.
You know, that's the old family of processors. There's faster ones now. So,
Yeah.
but yeah, so this I brought this up just because